friends, this is Sonam and today I am going to explain you what is square, square root, cube and cube root along with number of examples. If you enjoyed this video, please let me know by giving a video thumbs up. And if you have any questions, please let me know in the comment section below. And lastly, if you would like to see more videos like this, please hit the subscribe button. Let's begin. So what is square? Multiplying a number with itself. For example, 4. So square of 4 will be multiplying 4 with itself, which becomes multiplying 4 two times, called as 4 square. What is the pictorial representation? So this is 4. So 4 rows and 4 columns. This is pictorial representation. Similarly, if you look here, this is 2 having 2 rows, 2 columns, becomes 2 into 2. Value is 4 and the power form number of 2 are 2, so 2 raised to 2. In this case, rows are 3, columns are 3. 3 into 3 becomes 9 and this becomes total number of 3 are 2, so power is 2. Here 4 rows, 4 column, value becomes 16, power is 2. In case of this, 5 value 25 and this becomes 5 square. Whenever you construct a building, you need to form the base. Without base, you cannot construct the building. Similarly, in this case, if 5 is not present, there is no value of having a power. So 5 is called as base. And how many number of floors you have? This is first, this is second, this is third. So you are multiplying base that number of times. 1 time, 2 time and 3 times. So this is called as power. In this case, it is 2. And the value is called as standard form. Let's try to square few numbers. 1 square is 1. 2 square here is 2 into 2, which is 4. 3 into 3 becomes here 9. For the 4 square, which is equal to 16. 5 square will be equal to 25. Similarly, 10 square is 100. For 15, it becomes 225. Square of 20 is 400. 25 gives 625. And for 35, next number of 3 is 4. So 3 into 4 is 12. And square of 5 is 25. So becomes 1225. All these numbers are perfect square, as if you find a square of this number, that is again a rational number or a perfect square, and if you find the square root, again it comes out to be a rational number. We'll look at few more examples. Say if x equal to 4 upon 3. So to find a square, multiply it with the same number. Numerator into numerator will give 16 and denominator into denominator gives us 9. In case of multiplication, you just have to multiply numerator with its numerator and denominator to denominator. There is no need of making any base same or doing any other calculations. In this case, 1 upon 3 into 1 upon 3, which becomes 1 and 9. Here 3 upon 5 multiplied by 3 upon 5 gives, this becomes 9. This becomes 25. And in case of 0.26, you can find the solution with number of ways. You can convert it into the base of 100 and then you can multiply this. This will give you the value 676 and 1, 2, 3, 4. So 4 zeros. And then if you find the decimal, it becomes, so 1, 2, 3 and 4, and the decimal you place it here. If you don't want to go by this way, you can just do 0.26 multiplied by 0.26, and you can do the normal multiplication. Also remember, a into a is equal to a square, which means if it is 3, 3 into 3 becomes 3 square, which is 9. But a into a is not equal to 2a, which means 3 into 3 will not become 6, which is equal to 2 into 3. Now let's look at another example, and we'll try to find which statements are true and which are false. So first statement says 15 square is 15 into 15, and that is correct. As I said, a square is equal to a into a. So if this is 15, then it becomes 15 into 15. So this is true. Another is 20 square equal to 20 into 20, which is again true. It is of same type. 19 square is 19 into 19, which is again true because it follows this rule. Another is 81 square. 81 square will be equal to 81 into 81, but it says it is 2 into 81. 2 into 81 is different than 81 into 81. So this is false. 41 into 41 is 41 square, which is true with this rule. Next is minus 50 square is 2500. So 50 square is 5 square, 25, 10 becomes 20, so it becomes 2500. But in this case, minus is outside the bracket. So minus 50 square is equal to square of this number, which becomes minus 2500. So this and this is not equal. So this is false. This would be true if it would be this case, which means minus 50 multiplied by minus 50, and minus minus becomes positive. So we say like square of any negative number is positive. Now if you look at this example, minus 60 square. So minus 60 square means minus 60 multiplied by minus 60. So it becomes 3600, which is positive, which is true. Now in this case, x square equal to 2 raised to x. So to check this, you can take the value of x as 3. So x square will become 3 square, which is 9, and in this case it will become 2 raised to 3, and 2 raised to 3 is 8, which is not equal. 9 and 8 are not equal. So this becomes false. Okay, wait. Now what if I take the value of x as 2? So this will become x square is 2 square, and this 2 raised to again 2, which means equal. So this means like if the value is 2, then they are equal. But if the value is other than 2, then the value is not equal. You can try this out by taking different values of x. Okay, now, so this is false as well as true, and you can specify the condition where it's true and where it's false. Let's try to check this example. X square equal to 2 raised to 2x. So if you look, take the value with the x equal to 3. This will become 3 square. This will become 2 into 3. Now 3 square becomes 9 and 2 into 3, which is 6. Now 2 raised to any number for the power of 2 means 2 into 2, which is 4. 2 into 2 into 2, which is 8. So similarly, if you take any power, it will always be an even number in case of power of 2. So 9, which is odd, and this is even, so they won't be equal. In case if you are not able to understand this, you can actually find the power of 2 raised to 6 and then check they are not equal. Okay, now wait. So earlier we found like sometimes when the value of x is different, then it is true. Here it was true in case when x was 2 and false when the value exceeded with 2. Similarly, let's try taking it as 3, or let's try taking it by 2. So this will become 2 square and this will become 2 into 2. This is 4 and this value again becomes 4. Now 4 and 2 raised to 4. 2 raised to 4 is 16. So 4 and 16 are not equal. Now let's try to check from the list if they are perfect squares. As I said, it can be a perfect square if you can find a square of that number and you can get square root again from that number which is formed by the square. So let's see with this. In this case, now take which is the lowest number, which is 1, and the highest number is 64. So starting from 1, try to check the squares, which means 1 square, 1, this is perfect square. 2 square is 4, we don't have it in the list. 3 square is 9, okay, we have it, so it is a perfect square. 4 is 16, not in the list. 5 square is 25, not in the list. Next is 36, which is also not there. 7 square is 49 and we have it in the list. 8 square is 64, so we have 64 in the list. Sorry, the maximum number here is 80. So let's go with 9. 9 square is 81. Now we exceeded it. So last was 81 and the highest we have is 80. So we no need to check another numbers for finding the squares. So the one we marked here are all perfect square while the rest are not the perfect squares. Now let's see one more example. The number which is minimum is 4 and the maximum here is 125. So let's start from 1. You don't have to check. Square of 2 is 4. Okay, this is a perfect square. Then let's move forward. 3, 9, 4 with 16. So we have 16. 5 square is 25. It's there. Moving ahead, we get the next number as, so up to 81 we didn't find anything, nor up to 100 is 121 and 12 square is 144. So if you check, we have reached the maximum number. So maximum number was 125 and we have checked up to 144. So Whatever we tick marked here are perfect square and the rest are not the perfect square. For this next example, try to solve in the way we tried here and let me know your answer in the comment section below. The example says that the difference between two consecutive square number is odd number. So this is what we need to show. Let's go step by step. So what is square numbers? 1, 4, 9, 16. These are the squares of the numbers 1, 2, 3, 4 respectively. And so these are the square numbers. So what is consecutive? So 1, 2, 3, 4. These numbers come just one after the another. So these are called as consecutive numbers. So 1 and 4 are consecutive square numbers. 4 and 9 are consecutive square numbers. While if you take first and third, then they are not the consecutive square numbers. So now let's take these numbers and these are the squares, and what we have to check is the difference. Difference is subtraction. The difference between these two is 3. This is 5, 7, 9 and 11. So the difference between these numbers are all odd numbers.